Hi everyone, welcome back to my channel. This is Mr. Budihas, your online math teacher. In today's video, you will learn Introduction to Sets. At the end of this lesson, you will be able to clearly define a set, accurately represent a set using roster and set builder forms, correctly list all the subsets of a set, and correctly solve problems involving sets. Let's start. Let's learn first what is a set. In mathematics, a set is a collection of well-defined and distinct elements or objects. The elements that make up a set can be any kind of things, people, letters of the alphabet, numbers, places, colors, points in space, lines, other geometrical shapes, variables, or even other sets. When you say well-defined, it means it is clearly stated. For example, set A is the set of all integers between -4 and 4. And set B is the set of all colors in a rainbow. So this is well defined or clearly stated because we cannot think of any elements. For set A, all integers between -4 and 4, we can identify the elements. And for the colors in a rainbow, we can also identify the colors in a rainbow. This kind of representing a set is what they call statement form. Next, we have the roster form. All elements of a set are listed and enclosed in a pair of braces. We will just list all the elements of that set. So this kind of representation is what they call the roster form. For example, set A is equal to -3, -2, -1, 0, 1, 2, and 3. This is the roster form of this statement form. All integers between -4 and 4. Again, this is the roster form. They're just the same, but the thing is they don't have the same representation. Next, we have set B is equal to red, orange, yellow, green, blue, indigo, and violet. These are the colors in a rainbow. This is the statement form and this is the roster form. Next, we have the set builder form. It is when a common property of all the elements of a set is written. So we'll just describe the common property of all the elements. For example, set A is equal to the set of all x such that x is an integer between -4 and 4. Or we can write it in this way, the set of all x such that x is an element of an integer and x is greater than -4 but less than +4. So this way of representing a set is what we call the set builder form. This is just the same as, or somewhat like the same with the statement form. But here we can see this symbol, the set of all x, such that x is an integer between -4 and +4. Next, we have set B is equal to the set of all x, such that x is a color in a rainbow. Again, this way of representing a set is what we called the set builder form. Next, we have subset. A set A is said to be subset of another set B if all the elements of A are contained in B. That is, A is a subset of B. For example, if A is equal to 1, 2, 3, and 4, and B is equal to 0, 1, 2, 3, 4, 5, 6, and 7, then we say that A is a subset of B. Another example, if A is equal to 1, 2, 3, 4, and 5, and B is equal to 1, 2, 3, 4, 5 also, then we say also that A is a subset of B, even if they have the same elements. We can say A is a subset of B. Next, we have a proper subset. It is a subset denoted by this symbol. This is read as proper subset, which does not contain all the same elements of a set. For example, if set A is equal to 1, 2, 3, and 4, and set B is equal to 0, 1, 2, 3, 4, 5, 6, and 7, then we say that A is a proper subset of B. And we can also say that A is a subset of B. If A is equal to 0, 1, 2, 3, 4, 5, 6, and 7, and set B is equal to 0, 1, 2, 3, 4, 5, 6, 7 also, then we say that A is not a proper subset of B. But we can say here, A is a subset of B. Next, we have the empty or null set. It is a set with no elements. For example, set A is the set of all even prime numbers between 10 and 20. Set A is an empty or null set because there are no even prime numbers between 10 and 20. The only even prime number is 2, and that is less than 10. We denote that this set by A is equal to this symbol or this symbol. This represent or it means that the set is empty or null set. Next, we have the universal set. It is the set containing all objects or elements and of which all other sets are subsets. This is denoted by this symbol, U. For example, given that A is equal to 1, 3, 5, and 7, and set B is equal to 2, 4, 6, and 8, are subsets of the universal set. Then it is possible that the universal set is equal to 1, 2, 3, 4, 5, 6, 7, and 8. Again, this is possible that this is the universal set. Because since we have set A is equal to 1, 3, 5, 7, and set B is equal to 2, 4, 6, 8. We will just combine them, and this is the universal set. And these sets or these two sets are subsets of the universal set because we can find all the elements of set A to the universal set and also in set B. We can also find it find it in the universal set. Cardinality of a set. It is the number of elements in a set. We denote the cardinality of set A as the absolute value of A. Again, the cardinality will just count the number of elements in a set. For example, given that set A is equal to 0, 2, 4, 6, and 8, then the cardinality of set A is equal to 5 because we will just count the number of elements here. 1, 2, 3, 4, 5. There are 5 elements. Therefore, the cardinality of set A is equal to 5. Now let's try some examples of sets. Example number 1. Set A consists of all the positive integers less than 8, and set B consists of all the prime numbers less than 9. Represent set A in roster form and set B in set builder form. Here's the solution. For the roster form, We have set A consists of all the positive integers less than 8. So this is now the roster form. Set A is equal to 1, 2, 3, 4, 5, 6, and 7. These are the positive integers that are less than 8. Next, for set B, the set builder form, we have set B is equal to the set of all x such that x is a prime number less than 9. So we'll just put a pair of braces here, then write this, the set of all x such that x. Example number 2. Set A consists of all positive multiples of 3 less than 26. And set B consists of all positive multiples of 8 less than 89. Find the cardinality of set A and the cardinality of set B. Here's the solution. Since set A consists of all the positive multiples of 3 less than 26, then we have this. A is equal to 3, 6, 9, 12, 15, 18, 21, and 24. So we'll count all the elements in this set. You have 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the cardinality of set A is equal to 8. Never mind of the colors here. Now for set B, consists of all positive multiples of 8 less than 89. So the multiples of 8 are 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and 88. These are the multiples of 8 that are less than 89. So count them. Count the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the cardinality of set B is equal to 11. And that's all for today. Now I want you to answer these two problems under individual practice. And please do comment your answers below so that I can check if your answers are correct. For number 1, set A consists of odd integers from 40 to 54 and set B consists of even integers from 5 to 29. Represent set A in roster form and set B in set builder form. Second, set A consists of positive even multiples of 5 less than 60. Set B consists of odd multiples of 7 from 1 to 60. Find the cardinality of set A and the cardinality of set B.